Hi, and welcome to Geeks for Geeks. Today, we would be discussing yesterday's problem of the day, that is walls coloring 2. So, the feedback about this problem is that this problem is a variation of the wall coloring problem. So, basically, in the wall coloring problem, we are given a constraint that only three colors needs to be painted. Like we just need to choose among 1, 2, and 3, and it's time. So this problem is a standard version or a variation of that, where the k is big and we need to optimize on the k. So basically, to be honest, this problem is a DP optimization problem, the knapsack problem with an optimization, and that is it. Okay, so now let me just share the screen and I would just tell you the problem, because there is no point in reading the same old problem statement. I don't think you are here for that. Okay, so and it's good to go. Okay, so now, see, the problem is that we are given n walls. Suppose the given wall is 1, 2, and 3, and each wall can be painted with key colors. Suppose the first color is this, the second color is this, the third color is this, and the fourth color is this, and the fifth color is this itself. So now we need to understand that if we use this color to paint this wall, then in the next wall, adjacent, side by side. Adjacent means that the element which is just after that, it can be painted with this color, this color, this color, as well as this color. But it can't be painted with the same color as previous. So it is just like that. Suppose like a truth and dare game. So suppose the last time you took a truth, so in the next time you can't take the same truth again, you need to take dare. Here we have two options. That is why if we are not allowed to take truth, we take dare. If we are not allowed to take dare, we take truth. But in the case of K colors, if we use the last color, then we have K minus one other options. Like if from K options, if we remove one option, we are left with K minus one options. Okay. So now I would suppose you that this is a kind of level 2 of wall coloring problem, and the wall coloring problem is explained by me only, which occurred few days before. So I assume that you already know about wall coloring. If not, consider going back and learning about it. Okay, so I would just see, okay, good enough. So now let's go back. So now see, in this problem earlier we saw that we can simply do a wall coloring problem. So suppose the given value is that in the recursive case, suppose the this is the index I, and we want to color it with the red color. We want to color it with the red color. Okay. Or here we are given, so let's just quickly revise the concept of wall coloring. So if this is the index, this is the nth wall, let's say this is the ith wall. So if I want to paint ith wall with, let's say there were three colors, red, blue, and green, RGB. Okay, RGB. Okay, RGB itself. So if let's suppose I take the value of R. So if I want to paint the ith color with red, then I need to take the minimum of, like previous minimum of, ith minus 1th wall with gth color, like color G with color G with color G, and the next is I minus 1th wall with color B. So suppose currently, like suppose I want to paint the current wall with red color. So that means that previously I can't color it with red. Like if I want, suppose this is 1, 2, 3. Suppose I want to paint this one with red. Then this needs to be painted with G or B itself. Then this needs to be painted with G or B itself. That is why this is what? This is I. So I am taking the minimum of G and B of I minus 1. That is why to paint the wall with the red color, I am taking out the minimum of G and B. Here I am doing this. Am I clear till this point or not? Give me a quick 1 or 0. Okay, fair enough. This is clear. Now let's derive a relation from it. Okay, let's make this a little bit small. Okay, let's remove this also. Okay, it's fine. Now here we have only three options. That is R, G, B. We have only three options to paint. Okay, we have only three options to paint this. Okay, so here were three options to we are taking G and B. So what would be the time complexity of this approach? So basically, if you just see, we were filling I points, okay, I multiplied by K. And on each K, we were doing the minimum. Okay, now let's not do this. Let's first talk about this. So suppose the given problem is this, and I solved this point. Okay, this was wall coloring. Now in this problem, it is same, but here we are told that instead of just three colors, we have K colors. So I can say that if I suppose I can say that this is 1, 2, 3 dot 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 K, and I denote it with J. Okay, I denote it with J, and suppose this is 1, 2, 3 dot 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 N, and I denote it with what? I. And J is what? J is the color, and I is the wall. Okay, so now in the same scenario, okay, let's take the same scenario. If I want to paint ith wall with jth color, jth color, okay, if I want to paint ith wall with jth color, then it would be the minimum of I minus 1, I minus 1, I minus 1th wall from what? 1 to K, where J is not present. J is not, excluding J, or just write excluding J. Not present, we don't need to write. Excluding J. Excluding J itself. Okay, so see here, आर कलर हमने लिया, तो पिछला में आर कलर नहीं ले सकते, जी और बी ले सकते. सेम लाइक दिस, अगर हमने जे कलर यहाँ लिया और के कलर से, जेथ कलर लिया और यहाँ पे के कलर से, सो वो मिनिमम होगा 1 से लेके के तक, बट जे वाला वैल्यू नहीं होगा. Am I clear? Just give me a quick one. Like this derivation is clear or not? So now let's take this example. Mhm. Now let's see this. So now see, we are standing at I position and we are filling j values. So we are filling each I, we are filling each I and j values. So I in total we would be filling n walls with k colors. So we are filling n multiplied by k values. So here we are filling n multiplied by k values. Okay, like we would take a DP array of n cross k and we are filling each value. Now to fill one value, so to fill one value, we are iterating from 1 to k and only 1 is getting excluded. Okay, we are iterating from 1 to k, but the last element that is used, I am just excluding that. So it just means that I am doing k minus 1 operation to fill each value. So for one value, I am doing k minus 1 operation, ignoring the constant, I am doing k operation. So to fill how many values? N cross k value, I am filling up, multiplying n cross k on both sides. I am filling up k square n values. Okay. What is, so that means that this is the time complexity of what I am having. Minimum is an arithmetic operation, so that take constant time. So this is good enough. What is the value of k? Like in the worst time complexity, what is the value? So in the worst case, the value of k is 10 to the power 3. So 10 to the power 3 multiplied by square multiplied by 10 to the power 3, because n is also 10 to the power 3. Bases are same, powers would get added. 10 to the power 6 multiplied by 10 to the power 3, that is 10 to the power 9, and it is greater than 10 to the power 8. So we would definitely get a time limit exceeded error. Okay, the solution is correct, but it is not optimized. Okay, so done till this point. Now we would move forward. Okay, so let me just see which one, the last step we are talking about. Okay, so now see, we got the time complexity of n square k. We need to optimize it now. Okay, we need to optimize the solution itself. Now, at which point I can optimize the solution? This is an optimization problem. Okay, so now let's see. Okay, so I'm again asking. So for ith wall, I am, for the ith wall, to paint ith wall with jth color, we are taking out the minimum of I minus 1, I minus 1th wall with 1 to k. सारे कलर देखो एक्सेप्ट अगर हमें ith वॉल को jth से पेंट करना है तो I माइनस 1 पे जाके सारे कलर्स देखो बट j मत देखो। क्यों? क्योंकि करंट को j से प्रिंट करना है तो पिछला वॉल को किसी और से प्रिंट करना है। Now let us see how this value is getting added into the DPR. Okay, so now let's say specifically, okay, I would tell you that, don't worry, I would be doing a dry run today. That is why today I have not explained the test cases. Mhm. Okay, so now 4 multiplied by 3. So let's draw a DP array. Okay, okay, now quickly let us write. So suppose I want, so this is wall 1. So let us write, this is the first wall, or let's write W1, W2, W3, and W4. So see just carefully. To paint the first wall with the first color, I would just require a cost of 1 because I have no constraint. Like एक wall को red paint करना है तो adjacent तो हट ही गया ना। अगर एक ही पेड़ है और कुछ अगल बगल है ही नहीं तो अगल बगल के कोई कंडीशंस भी एग्जिस्ट नहीं करेंगे। So if we have only one element, then the condition of adjacent is not applied. That is why to paint the first wall with the first color, we would have a cost of 1. To paint the second wall with second color, I would have a cost of 5. And then 3 and then 1. Okay, simple enough. Now, to paint the first wall with this color, okay, that means first I would, ये color तो paint करना ही है. So first मुझे 5 लगेगा. And then previous, what would be the previous? So if I am painting this wall with the first color, then it would be the minimum of all this, because अगर ये कलर से पेंट कर रहे तो ये कलर तो नहीं ले सकते, बाकी सारा ले सकते हैं. That is why the minimum of all this is 1, that is 6. Okay, 5 plus 1, that okay, let's do this. Now to paint this one, first I would require this. अगर हम इसको पेंट कर रहे हैं, अगर हम इसको रेड से पेंट करें तो फर्स्ट में रेड का तो कॉस्ट लग ही जाएगा ना. अब पिछला के बारे में सोचते हैं. So if I am painting with the second color, that means I can't paint the previous one with second. So I need the minimum of others. So 3 1 1, minimum is 1. So 8 added to 1. Then 2. So first I would just color it with 2. And if I am coloring with the third color, then the minimum of the rest color, that is 1. So this is just 1. And if I'm coloring the fourth one with fourth color, that is 2. And the minimum of first 3 is just 1. So now let us just replace the addition. 5 plus 1, 6. 8 plus 1, 9. 2 plus 1, 3. 2 plus 1, 3. Okay. Fair enough till this point. Now let's see the third one. Here I would tell you the optimization. So now see, the problem is that suppose I want to paint with this color. That means I would require a cost of 7 and the rest minimum 933. I can take 3. If I'm painting it with 4, I would require 4 and the minimum of rest 633. So 3. Okay. 4 plus 1, that is 4 plus 3. Yes. Uh-uh. Okay. So I'm just taking the walls this side. Here the walls is that side. Okay, here's the walls is that side, but here I'm taking this side. So now see, if I'm painting with this one, then I will require the cost of 9 and there are 693. Minimum is 3. So now if you see that basically what? Basically to paint it with red. Red cost, basically to paint it with red, I would first add the cost. Suppose to paint it with 9, to paint it with this one, I first require 9. तो द कॉस्ट, सपोज मैंने ठान लिया कि मैं इसको रेड से करूंगा, तो जो रेड से करूंगा उसका तो कॉस्ट लगेगा. Suppose I decided that I would paint it with red. So to paint it with red, I would require the cost of red first, and then the minimum cost apart from red. Okay. So basically, we are finding the minimum among all this except this. Except this. Minimum except this. Okay. So now I want the minimum every time. That is why I'm iterating on K again and again. So the last K we are iterating is because of this. That we are iterating on all the K. Like K colors पे iterate कर रहे हैं, एक color छोड़ के, suppose मैंने red किया, suppose RGB है. The last color I colored was R. So then I was iterating on GB, minimum of GB. Here also we are iterating on all the colors except the last color, except the current color. Okay. So मुझे minimum चाहिए एक को छोड़ के. Okay. So minimum leaving one element. So now my question is, I want minimum leaving one element. एक एलिमेंट कंसिडर मत करो और मिनिमम लेके आओ. दिस इज वाई वी आर इटरेटिंग ऑन के. दिस इज वाई इट इज. सो आई वांट दिस. सो हाउ कैन आई गेट दिस? सो इफ आई टेक आउट द मिनिमम, लाइक मैं एरे से पूरा मिनिमम निकाल लूं. ओके. सो सपोज वी हैव 5 3 1 2. Okay. So I know that the minimum of this array is 1. Okay. So if the element to be left is 1, then सही है. What I'm trying to say is, suppose if I know that 5 3 1 2 में सबसे छोटा 1 है, तो अगर 3 को इग्नोर करना है तब तो सही है, वो मिनिमम नंबर पे फर्क नहीं आएगा. Okay. But what about the scenario when the minimum number is only the number that we need to take out? What would be the scenario when the minimum number that we are taking out, the the number we are leaving, this leaving one element is the minimum element itself? Then the answer would be what? Okay. So now there are two scenarios. Suppose we found out the minimum element. We found out the minimum element. Now to remove one element, it can be two scenarios. Okay, so now suppose I want to remove one element. Now that element can be the minimum element. Okay, first let us take, agar suppose 5 3 1, let's take the example 5 3 1 2. Suppose I find out, what was this? Yes, minimum leaving one element. Minimum, let's write it again so that you don't forget. Minimum leaving one element. So suppose I found out the minimum. Minimum is 1. Okay, I found out. So if the value is 3, then it is good to go. Then answer is not affected. But what if the element to be removed is the minimum itself? Then answer would become, answer is equals to second minimum. अगर मिनिमम को ही हटा दिया तो सेकंड मिनिमम would be there. Suppose there are suppose there are, like, suppose we are given that there are three people, one of 10 years, one of 9 years, one of 3 years. Okay, and the person oldest would get married. Okay, let's not take this much. Let's say that there are three brothers. Okay, that is 41, 45, and then 36. Okay, now suppose the person who is the oldest needs to get married. Okay, okay. Now suppose the person who was going to get married, that is 45, who is the oldest, about to get married, because of some unwanted circumstances he dies. So which person would marry? The second oldest would marry after that. In the same manner, if the minimum only we are removing, then the answer would become the second minimum. Else, if suppose here instead of 45, suppose because of some unwanted circumstances 41 was not able to survive, so 41 would still get married. Okay, 41 would still get married because he is still the oldest. So if other number is removed, we don't get affected. But if the current minimum is only getting removed, then so basically what we do is we do the same thing, but this time we find out minimum and second minimum. Okay. So if the last value was minimum, then we consider the second minimum. If the last value was not minimum, then we consider minimum only. Rest, the code is of akin to the wall coloring 1 itself. Now I would move to the coding part. I hope it is clear. So am I clear, Rishit? Just give me a quick yes or no. Yes, so keep a track of minimum and second minimum at each step. The color given in the row is in the row wise or column wise. Basically, it is given the opposite of what I have drawn in the in my this board. That is the board on which I am explaining. Okay, by mistakenly, specifically y n h squared, not n h squared, k h squared. Okay. So what about Devansh? Am I clear to you, Devansh? Just give me a quick yes or no. Okay. So now I would just move forward. So let's do the same thing only. Yes. Let's see. Okay. So I would say I would first find n cross n and m because we are not given the value of rows and columns. So number of rows is equal to s dot size and number of columns, like in k, n cross k is equals to cost of 0 dot size. But as we are accessing the very first element, so what is the value of n? N can be 0 also. So we are trying to access the first element, but it might be the scenario that the first element does not exist. So I would say if n is equals to 0, okay, we would return 0 here only. Okay, else we would take the value. Now if k is equals to 0, because we are told that k can also be 0. So if the number colors available to us is not there, if we have no colors to paint, if we have no colors to paint, then the cost to paint with no colors is 0. So now I would say that the first minimum, okay, the first minimum and the second minimum. So int max, we would initialize both the first minimum and the second minimum with int max only. Okay, and then I would make a 2D vector. So vector, let's say dp of n cross k. So n cross k, that is 3 into 3, but a dp array of size 10 to the power 6 behaves abruptly sometimes, so I won't take a risk. Vector int dp of size n comma vector int of size k itself. Okay, fair enough. Now we would start the iteration. For int I is equals to 0, less than I is less than k and I plus plus. And then we would say dp of 0 comma I is equals to cost of 0 comma I itself. Okay. The cost to paint the first wall with whatever be the color is the same itself. Like if I want to color the first wall with red, then there is no previous one. No? So if there is no previous, we don't have any constraint, so we don't need to consider anything. Just directly assign it. Okay, like पहला ही wall है और उसको मैं रेड से करना चाहता हूँ. तो पहला ही वॉल है, उसके पिछला मुझे कुछ देखने की जरूरत नहीं. इसके पहले अगर मैं रेड से करना चाहूँ तो इसके पिछले कुछ है ही नहीं. इससे पहले रेड हो ही नहीं सकता क्योंकि पहला वॉल है ना. So if it is the first wall, we don't need to care anything. Just directly say, if you want to paint red, paint it with red. This is the cost. You want to paint it with blue, paint it with blue. This is the cost. Okay. Till this point, I'm done. Now I would say that if C of 0 of I is less than min 1, okay, then I would transfer that value to min 2. Min 2 is equals to min 1. Like suppose I found a better value than min 1. Okay, so now better value. So second most better value would go to min 2. So second most better value is going to min 2. And min 1 is equals to cost of 0 comma I. Like suppose I saw that min 1 is the best, but now suppose I found a better than min 1. So better would go to min 1 and min 1's value would go to second minimum. Okay. Else, if this is the thing that cost C is equal to, else if C of 0, okay, else if C of 0 comma I is less than min 2, okay, if this is the scenario, then min 2 is equals to C of 0 comma I itself. Okay, so now we have decided everything for the first wall. Okay, after all this, if we need to paint only one wall, okay, then we would simply return min 1. So let's make this code a small one, more space so that a large of you can keep a track of this. Yep. As of now, this is the most concise code. Okay. After this point, we would start the iteration. We would say C of min1 is equals to again int max comma C of min2 is equals to int max. Okay. C of min1 is also int max, C of min2 is also int max. This is basically the current minimum. Like that is the global minimum and second global minimum. This is current minimum and current second minimum. Okay. After this thing, we would start the iteration for int I is equals to 1, I is less than n, and I plus plus. And then I would say for int j is equals to 0, j is less than k, and j plus plus. After all this, if I would say that if dp of I minus 1 and j is not equal to min 1, let's suppose the oldest brother who was about to get married, he didn't met with an accident. If he didn't met with an accident, then he would be the one he would be the one who would marry first. So no difference in the marrying thing. So dp of I and j, dp of I and j is equals to c of I dash j plus min 1, like the minimum of it. Else, if this is not the scenario, then dp of I dash j is equals to c of I dash j, else second minimum. Like if the oldest brother died, then the second person who is the second oldest would marry that. Okay, this is done. Okay, after this is done, we would update the current minimum with this thing. Okay, so after this thing is done, we would say if dp of I dash j is less than c min 1. Okay, then the same thing, c min 2 is equals to c min 1. The same explanation of here. Okay, and c min 1 is equals to dp of I dash j itself. And then else if dp of I dash j is less than c min 2, so this is the scenario, and c min 2 is equals to dp of I dash j itself. Okay, this is the scenario. After this for loop, we come out. Okay, and we say that so cp of cmin, now we need to update it after coming out of this for loop. So we would say min 1 is equals to c min 1 and min 2 is equals to c min 2. Like the current minimum would become the global minimum now. Okay, and c min 1 would again reset it to its previous value. C min of max, C min 1 would become max, and C min 2 would also become int max. Okay. After all this, if the minimum 1, okay, if the minimum is still less than 0, that means we were not able to paint all the values. That means it is minus 1. Okay. Else, we are coming here, that means we are able to paint. So that value would be nothing but the minimum value itself. So let us just compile and run and see how many errors are we making. Okay, fair enough. We made the very first error. Okay, we are getting correct output for the sample test case. Fair enough. We got an AC. Okay. So I would share the tab itself and you tell me the point at which you were not able to understand. So this is the thing. So tell me the point at which you were not able to understand. We should on line number, so keep a track of minimum. On line of 23, should we have minimum is less than because both the minimum could have the same value when a value occurs more than once. So see, if the minimum value occurs more than once, suppose there are two people, like suppose that is why I keep the example of brothers. Suppose there were two brothers with age of 45 and the next brother was 34. So if the first brother of age 45 dies, then the next brother of age 45 remains. So if the person who is the oldest needs to get married, then the next person with age 45 would get married. So the element remained the same, but the person changed. The age remained the same, but the person changed. So the value is not important to us, but the index of the color we are using, that is important. So am I just do I make sense to you, Rishi? Just give me a quick one. Okay, so I see no more else popping out. So that was it from my side. So if you still face any issues, feel free to just comment it out. As just if you are not able to find a solution, ask your friends or your teachers. If still not and you are helpless, then you can reach out to me on LinkedIn. Okay, so now the next thing is that if you're watching the stream in the recorded version, feel free to like and comment the video so that the reach of this video could be increased and this work could be justified. That was it for today. Thank you and have a nice day. Good night, everyone.